Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 2 video on the chapter of playing with numbers, where I will solve some practice problems based on the topics that I have discussed in the previous video, that is part 1, which was general form of numbers and games with numbers. So this video is part of the playlist CBSE Maths for Class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, or if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the practice problems based on the general form of numbers and games with numbers. Okay, so I have the set of problems, practice problems on the left hand side, which are based on the general form of numbers and the games with numbers, which are discussed in the previous video, that is part 1. If you have not watched the previous video part 1, then I strongly suggest that you watch that video first before solving these problems or seeing this video on the solution of this problem. So if you have watched that video, then I hope you will be good to solve these problems. It is recommended that you try to solve these problems yourself first, and if you are stuck at any problem after multiple attempts, then you can see this so you can refer this solution video. Okay, let's start solving the problems. Let me quickly check if everything is visible properly or not. Okay. The first problem says that the usual form of 1000D plus 100A plus 10C plus B is. So the number is given in general form, and we have to uh, express the number in general form, given in general form, in usual form. So we know that 1000D. Now whenever a number in general form is given like this, how do we know the digits uh, at the different places of the number? Now, if you have, so we know that any number in the general form, any term in the general form rather, if it is of the form, it will definitely be of the form digit, that is digit multiplied by 10 to the power n minus 1, where n denotes the fact that the digit is at the nth place from the right hand side. If I consider a digit, if I consider a number, let's say A, B, C, D, the rightmost digit is the D, which is the digit at the units place, and the leftmost digit is A. So the digit, the rightmost digit, its place serial wise is 1. This is the second digit. This is the third digit, and this is the fourth digit from the right hand side. So if you have in the general form, if you see a term of the form 10 to the power n minus 1, where n is definitely a natural number, which is n is a natural number, and you have digit. So this will imply that the digit is at the nth position from the right hand side in the number. Okay, so now we can identify the digits. We can see that 100, this is equal to 10 cube multiplied by D, this is equal to 10 square multiplied by A, this is equal to 10 to the power 1 multiplied by C, and B we can write it as 10 to the power 0. Any natural number to the power 0 is always 1, and we can write a B as 1 into 1, and 1 we are expressing as 10 to the power 0. Now so number in usual form will be the digit d from the leftmost term is 10 to the power 3 multiplied by d. So we can clearly say that the digit d is at the position 3 plus 1, that is fourth position from the right hand side. So definitely this is a so d. Now as you can see, there are four unknowns. So definitely there must be at least four digits in this number. Now, since just by saying a number in the general form, if you see there are four unknown digits or three unknown digits. If there are four unknown digits, that does not mean that the number will be four-digit number. You have to see the highest power of 10. In this general form of the number, the highest power of 10 is 3. That highest power, that is 3, from that you can identify how many digits in the number will have, and that number of digits will be the highest power plus 1. So in this general form, we can see the highest power is 10 to the power 3. So this number will have 3 plus 1, that is 4 digits. Okay, so we know that the digit d will be at fourth position from the right hand side, since its power of 10 is 3. Similarly, the power of 10 of the digit a is 10 square. So its digit the position of the digit a will be 2 plus 1, that is third position from the right hand side. So definitely it will be to the right hand side of d. Okay, and the c its power of 10 is 10 to the power 1. So its position from the right hand side is the power is 1, so 1 plus 1 2. So definitely it will be to the right hand side of a, that is c. And we know that the term b is 10 to the power 0 multiplied by b. So 10 to the power 0 means its position is 0 plus 1, that is the first position from the right hand side. So this is the number DACB. So the correct answer is the correct choice is D. So while I am solving the problem, you can take screenshot of the solution. Okay. Let's do problem number 2. Find the number of digits in the number. So a number in the general form is given as 10,000 into P plus 10Q plus R. Now, even though there are three unknown digits P, Q and R, the only thing that will matter in finding the number of digits in the given number whose general form is given is from the highest factor of 10, highest power of 10. So all the numbers are multiplied by some power of 10. So R, it is multiplied by 1 we can say as 10 to the power 0. Q is multiplied by 10 and P is multiplied by 1000. So the highest power of this is equal to 10 cube into P plus 10 to the power 1 into Q, and this is 10 to the power 0 into R. So the highest power is highest power of 10, highest power of 10 in this general form is 3. So this will imply number of digits is equal to 3 plus 1, that is 4. So this is the given general form of a number is of a 4-digit number. So the correct choice is C. Okay. Let's do problem number 3. It is given that 5a, now 5a do not consider is at 5 multiplied by a. It is a 2-digit number in usual form, where a is the digit at the units place and 5 is the digit at the tens place. So it is given that 5a plus 25 is equal to B2 is equal to B2. So definitely A and B must be some digits. Where A and B are digits, then the value of A plus B, we have to find the value of the digit sum of the digits A and B. Okay. Now we will use the concept of general form of a number to find the value of A plus B. So 5A, it is the number in usual form. Its general form will be 5 multiplied by 10 plus A. And we have plus 25. And the right hand side, the number B2, which is in usual form, its general form will be 10 multiplied by B plus 2. If we simplify further, we get 50 plus A plus 25 is equal to 10B. Then A and B are digits, find the value of A plus B. Okay, so A plus B. Okay, so we have 50 plus A plus 25 equals to 10B. Okay, this implies uh, this implies 75 plus A is equal to 10B. 10B. This implies we are getting uh, 75 equals to 10B minus A. 10B minus A. Now, if 5A, now how do we know, how do we find the digits A and B? We have to find the value of A plus B. 5A plus 25 is equal to B2. Okay, so 5A plus 25, 5A in the general form will be 5 into 10 plus A, and we have plus 25 equals B2 is 10B, 10 into B plus 2. And then we have 50 plus A plus 25 equals 10B. Oh, it is 10B, sorry, 10B plus 2. 10B plus 2. Five A plus 25 is equal to B2. Where A and B are digits, and find the value of A plus B. So we have 75 plus A equals to 10B plus 2. BA. The A and B are digits from 5 into 5A is 50 plus A plus 25 is 10B. B2 is 10 into B plus 2. 10B plus 2 plus A. 73 plus 2a. From this given equation, we can say that 5a minus, no, sorry, we can say that 25 is equal to b2 minus 5a. b2 minus 5a. So when we do a normal subtraction, let's say this is the number b2, and definitely so b2 is greater than 5a because the difference is 25, which is a positive number. So in general, when we subtract two-digit number, so we are subtracting 5a from b2, we are having the result as 25. Now we are having the result 25. Now a, definitely a is greater than 2. That is why a is greater than 2, and so we can say that since the result of the difference, the units digit is 5, we can say that 12, uh, applying the basic concepts of subtraction from the right hand side, we can say that 12 minus a is equal 5. This implies a is equal 7. A is equal to 7. Okay, and there will be a carry forward, and we can say then this will also imply applying the basic concept of subtraction. So we have a carry forward, and the 5 will 1 will get added to 5, and we can say that b minus 6 has to be equal to 2. This implies b is equal to 2 plus 6, that is 8. So the number should be no, not number, but a is equal to 7 and b is equal to 8. Their sum should be 15. Now let me quickly check if I did it correctly by putting back into the equation 5a plus 25 equals to b2. So so we must have b is 8, so we must have 82 minus 57 equals to 25, and I hope this is correct. Okay, so a is 7 and b is 8. This implies a plus b is equal to 7 plus 8 is equal to 15. So the correct choice is A. A is the correct choice. This problem is actually was not based on the general form of numbers, but it is actually a problem based on uh, filling the missing letters based on the subtraction and addition of digits, not numbers, two-digit numbers or three-digit numbers. There will be some missing letters, and you have to fill those letters with some digits. This problem was based on that pattern of question. So this problem should not have been in this problem set. So all these problem set are based on, I have tried my best to create this problem set based on the general form of numbers or the games with numbers. Okay, let's do the problem number 4. If the general form of the number 9pq5 is, it is given that the number in usual form is given as 9pq5. So there are two unknown digits p and q, and it is a 4-digit number. Its general form is given as 1000 into a plus 100 into 7 plus 1 into b. So this is basically 10 cube into a plus 10 square into 7 plus 10 to the power 0 into b. So ideally, from the right hand side, from the general form, we can say that the number, that the 4-digit number should be the fourth digit from the right hand side should be a, because it is having a power of 3 of 10. So a will be the leftmost digit, and then we have 10 square. The digit 7, it is multiplied by, it is having a factor of 10 square. So its position in the digit, in the number, will be third. It is the third digit from the left right hand side. So we have a 7, and there is no digit, there is no term having a factor of 10. So definitely the second digit from the right hand side has to be 0. And we have a b, 10 to the power 0 multiplied by b, which means that the digit b is the first digit from the right hand side. So we have b. So according to the general form, the 4-digit number should be A70B, but it is given that the 4-digit number is 9pq5. So we have to now just match the digits, match these two numbers are equal. These two numbers in usual form are equal, or are the same numbers, or denote the same 4-digit number. So we can just do a comparison of the corresponding digits and find the value of a plus b plus p plus q. Okay, so we can clearly say that a has to be equal to 9, p has to be equal to 7, q has to be equal to 0, and b has to be equal to 5. So this implies a plus b plus p plus q is equal to 9 plus 7 plus 0 plus 5, which is equal to 21. So the correct choice is B. B is the correct choice. Okay, let's do the next problem, problem number 5. The problem says let n is the 4-digit number x, y, z, w. So the digits are x, y, z, w. Then the value n minus x minus y minus z minus w is divisible by, okay. So the given 4-digit number is x, y, z, w, which is equal to n. So n is given to be the digit. So n is a 4-digit number, and the digits are x, y, z, w. And so its general form, if we express this number n, this 4-digit number x, y, z, w, in the general form, it will be 1000 into x plus 100 into y plus 10 into z plus w. Now it is asking, then the value of this implies n minus x minus y minus z minus w will be equal to, if we replace n by its general form, we have 100,000 x plus 100 y plus 10 z plus w, and then we have minus x minus y minus z and minus w. So WW gets cancels out, and we are left with uh, 1000x minus x plus 100y minus y plus 10z minus z. This is equal to 999x plus 99y plus 9z. So clearly we can see that we can have 9 as common factor, and this becomes uh, uh, 111x plus 11y plus z. Now we do not know what will be the value of 111x plus 11y plus z, but we can definitely say that this number n minus x minus y minus z minus w will be divisible by 9. So the correct choice should be C. We can say that this is divisible by 9. So the correct choice will be C. C is the correct choice. Okay, let's do problem number 6. It says the sum of all the numbers formed by the digits x, y and z of the number x, y, z is divisible by. The sum of all the numbers formed by the digits x, y and z of the number x, y, z is divisible by. Okay. So what are all the numbers formed by the digits of a 3-digit number? So the number is, so the first number has to be the given original number x, y, z. So this number in the general form is 100x plus 10y plus z. Another number we just have to change the positions of the digits x, y, z and to form all the numbers. So the second number we can interchange the position of y and z. So we have x, z, y. Consider this number. This will be, the general form will be 100x plus 10z plus y. Now let's say we have yz. Let's say we put okay. So let's say put x in the tens place. So we are left with y and z. Let's say yxz will be equal to 100y plus 10x plus z. Now let's keeping the position of x intact, same, change the position of y and z. That will give another number, that is zxy is equal to the general form. So on the left hand side I am writing all the different numbers possible from the digits x, y, z, and on the right hand side I am writing its corresponding general form. So zxy, its general form is 100z plus 10x plus z. Now let's put the x at the units place. X. Now we have to place the y and z at different positions. Let's say yz x, its general form is 100y plus 10z plus x, and let's now interchange y and z. We have zy x is equal to 100z plus 10y plus x. I hope these are all the numbers possible using the 3 digits xyz, 3-digit number. So these are all the possible 3-digit number from 3 digits xyz. Now if I add all of them, so I get that sum of all numbers is equal to, now let's see, we have 100x 100x two times, so that becomes 200x, and we have 10x two times, that makes 20x, and we have x two times, so 2x. Similarly we will have 200 y plus 20y plus 2y, and uh, we will have 200 z plus 20 z plus 2z. So this is equal to 200 plus 20, 200x plus 20x plus 2x is 2, 2, 2x. Similarly, we will have 2, 2, 2y, and we will have 2, 2, 2z. So this we can take 200 and 222 common, and we have x plus y plus z. So these, the sum of all the numbers formed from a 3-digit number xyz by changing the positions of the digits xyz is 222 multiplied by x plus y plus z. Now, okay, uh, the choices are 11, 33, 37, and 74. Now, if we can break down, if we break down the 222 by its factors, we have 2 into 111, and we have x plus y plus z. Now 111 can also be broken down as 3 multiplied by 37. So we have 2 multiplied by 3 multiplied by 37 multiplied by x plus y plus z. All the sum of all the numbers formed from 3 digits x, y, and z is equal to 2 into is actually divisible by 2, 3, 2 and 3 and 37 and the sum of their digits. So definitely the correct choice, so this number, the sum of all the numbers, is definitely divisible by 37. So the correct choice is C. Correct choice is C, because no other numbers x plus y plus z we do not know. The other choices could be 2 or 3, which is not in the choices given. So the correct choice is C. Okay, let's do problem number 7. A 4-digit number AABB is divisible by 55. Then possible values of B are a 4-digit number AABB is divisible by 55. Now this problem is also based on the divisibility of numbers, which I have not discussed. In part 1, I only discussed about the general form of numbers and games with numbers. Games with numbers are basically word problems based on general form of numbers. Now this problem number 7, is, to me it seems it's based on the divisibility of numbers. Now let's see if we can apply the concept of general form of a number to solve this problem. So a 4-digit number is AA is given as AABB. So its general form is 1000A plus 100A plus 10B plus B. This is equal to 1100A plus 110B. This is equal to 1100A and 11B. Now this is equal to, we can see 11, we can take 11 common factor, we can see this is 100A plus B. So this number AABB, whatever the digits A or B, irrespective of the digits A and B, this number AABB is definitely divisible by 11. Now it is given that the number AABB is divisible by 55. Is divisible by 55. So this will imply that is divisible by 55. So this will imply that 100A plus B must be a multiple of 5. If multiple of 5, only if 100A, this term 100A plus B is a multiple of 5, only then the whole number, that is 11 into 100A plus B, will be divisible by 55, because if 100A plus B is a multiple of 5, we can say we can express this as 11 into, since 100A plus B is a multiple of 5, it will be of the form 5 into m for some natural number m, and this is equal to 55 into m, and whatever the natural number m be, it will be divisible by 55. So 100A plus B must be a multiple of 5. So now it is asking what are the possible values of B, what are the possible values of A and B. Now since the whole number AABB is a multiple of 55, now what is 100A plus B? This number 100A plus B must be a multiple of 5. Now this number 100A plus B, we can consider it as a 3-digit number, where 3-digit number like A, 0, B. 100A plus B, we can consider it as the general form of the 3-digit number A0B. So the digit at the units place is B, and the digit at the hundreds place is A, and the digit at the tens place is 0. So this will make the general form of the 3-digit number A0B as 100A plus B. Now this number is a multiple of this number is a multiple of 5. A0B is a multiple of 5. So this implies B can be the digit B at the units place. We know any number, if it is divisible by 5, then the digit at the units place has to be 0 or 5, can be 0 or 5. B can be 0 or 5. Now we have to see the choices. The choices A. So from this fact, we know that B can be either 0 or 5. So from this fact, we can rule out, eliminate the choices A and D. Okay. Now the choices B and C. Now the choices B, it says B, the possible values of B can be 2 and 5. Can B have the digit B have the value of 2? No, it cannot. We have already found that B can be 0 or 5. So definitely the choice is C. C is the correct choice. So ultimately, we using the general form of numbers and a little bit of concept about divisibility of a number by 5, we have solved this problem. So first we have expressed the number AABB in the general form, which turns out to be 11 into 100A plus B. Now since it is given that AABB is a multiple, is divisible by 55, we can clearly say that 100A plus B has to be a multiple of 5. Only then 11 into 100A plus B will be divisible by 55. So we got 100A plus B is a multiple of 5. Now 100A plus B can be considered as the general form of a 3-digit number A0B. Now if A0B is a number, a 3-digit number which is divisible by 5, then it is very obvious that the digit of the units place, that is b, has to be 0 or 5. Okay, let's solve problem number 8. A 6-digit number xyz. Okay, so xyz is repeated twice. A 6-digit number is formed by repeating a 3-digit number xyz. Then such a 6-digit number is divisible by. Okay, so the number given is x, y, z, and again x, y, so z. So this is a 6-digit number. Now, if you observe, this can be written as whatever the 3-digit number xyz, that multiplied by 1000 plus xyz plus xyz. Now, how do we get this? How am I saying that the 6-digit number xyz will be equal to the number 3-digit number xyz multiplied by 1000 plus xyz? Because from the numbers, I mean, these things should be very clear from concepts you have studied in class 6 or 7. That is, concept about place value and the digits. So 123 is definitely is equal to, you can, if you consider some digits from the left hand side, some consecutive digits from the left hand side, let's say 112, then you can say that this will be equal to, we know that 12 into 10 plus 3. 12 into 10 plus 3. Now, how come 12 into 10? Why it is 10? Why it is not 100? So, it is 10, 12 into 10, it is 10 because to the right hand side of the number 12, we are having one digit, that is 3. That is the reason it is 12 into 10 plus 3. Similarly, let's say 4, 5, 6, 1 is equal to, I can say 4 into 1000 plus 561, because I took the leftmost digit and multiplied it with 1000. Why 1000? Why 1000 means 10 to the power 3. So why 10 to the power 3? Because to the right hand side of the digit 4 we have 3 digits 561. So this number 4561 will be equal to the digit 4 multiplied by 10 to the power 3 plus the number formed by the remaining digits, that is 561. So this is the logic why if you consider the digits xyz, so the digits xyz, if you consider that as a number, 3-digit number, in the original 6-digit number, which is xyz, if you consider only the leftmost 3 digits, that is xyz, to its right there are 3 more digits. So this whole number, 6-digit number, can be expressed as, if I take the leftmost 3 digits, then xyz, that multiplied by 10 to the power 3, which is 1000, plus the remaining digits, which is also to the right hand side of the first leftmost 3 digits, we also have xyz. So this is plus xyz. Now if you simplify this, we get 1001 multiplied by x, y, and z. Now we do not know, so xyz can be any digits. Xyz can be any digits. Now from this fact that xyz being any digits, a 6-digit number of the form xyz and xyz is definitely divisible by 1001. But what will be xyz, we cannot say. We have no idea about xyz. So we cannot say we know that this the number xyz, this 6-digit number xyz and xyz is divisible by 1001 and xyz. Whatever the digits xyz are, their product will also be a the product of the digits xyz will also be a factor of the 6-digit number xyz and xyz. So from the given choices, we can say that the correct choice is D. The correct choice is D. Now, what is choice A? It is saying 7 only. 7 only. Now, I have to see whether 100 and 1001 has any factors or not. Now, the choice A, B, and C are saying only 7, 11, and 13. So, it is quite possible that 7, 11, and 13 are factors of the number 1001. So, let me check quickly. 1001, if I divide by 7, I have 7, 3, and 4, 28 to 1. Yes, it is indeed divisible by 7. So, this is equal to 1001 is equal to 7 multiplied by 143, and we have xyz. Now, do we have any factors of 143? It seems yes, it is divisible. 143 must have a factor of 11, and we get 1 and 13. Okay, so 1001 is basically 7 into 11 into 13. So this is the number that we are getting using the 6-digit number xyz and xyz must be divisible by 7 and 11 and 13 and the product of the digits xyz. So the choices are only 7. No, it is not divisible by only 7 because it is also divisible by 11, 13 and xyz. The choice B is only 11. So the only ones are not correct. Choice A, B, and C are not correct because they are saying only divisible by 7 or 11 or 13. So they are incorrect. So the choice D is saying that the number 6-digit number is divisible by 1001, which is a correct statement because we can see that the given 6-digit number xyz is equal to 1001 multiplied by xyz. So it has to be divisible by 1001. So the correct choice is D. Correct choice is D. Okay, let's solve the problem number 9. Okay, there are only 9 problems. No, there is how many problems? Oh, there are 12 problems. Okay, 9. It says that 5a multiplied by a is equal to 399. Then the digit a is, now over here the left hand side, 5a multiplied by a. Now 5a is not 5 multiplied by a, it is a 2-digit number where the digit at the 10 units place is a and the digit at the tens place is 5. So if we write the general form, if we express 5a in the general form, we get 50, that is 5, we get 5 into 10 plus a, and we have this multiplied by a is equal to 399. This implies 50 plus a multiplied by a is equal to 399. This is equal to 50a plus a square is equal to 399. Now the number 50a, whatever the digit a is, irrespective of whatever digit a is, the number 50a, this number, its digit at the units place will always be 0 because this 50 is 5 into 10 into a. we have plus a square equals to 399. Now, if you multiply a number x is the natural number. If you multiply this by 10, obviously the digit at the units place, unit digit uh, of x into 10 will always be equal to 0. If we multiply any natural number by 10, the digit at the units place is always 0. Okay, so we can see the given number on the right hand side, the number is 399 and the digit at the units place is 9. And so this will imply that so this this number has 0 has digit has digit 0 at units place, not units place. So if we are adding number which has the digit 0 at the units place with the number a square, then the unit digits unit we can say that digit at the units place, digit at the units place of of 5 into 10 into a plus a square will be equal to digit at units place of a square, because the number 5 into 10 plus a is having a digit at the unit place as 0. So when that number 5 into 10 into a is added with a square, so definitely the result will have the digit at the units place which will be based on the digits at the units place of a square. Now this implies that digit at digit at units place of a square is equal to 9, because we have given that the whole number, that is 5a multiplied by a, is equal to 399. So we can see that the digit at the units place of a square is equal to 9. Now what can the digit a be such that that digit multiplied by digit itself gives 9? That only happens when a is equal to 3. There is no other digit. If you multiply the digit with itself, it will give the result where the units digit is 9. Now okay, there can be, if the digit is 7, if the digit is 7, a is 7, then 7 multiplied by 7 is 49. 7 multiplied by 7 is 49. In that case, the digit of the units place of a square can be 9. Also if the digit, also if a is 3, 3 into 3 is 9. So the possible values of a is 3 and 7. But it is asking, since it is a multiple choice question, it is asking that then digit a is, it must have a single value. So from our solution so far we have solved, it seems that a can have the value of the digit a can be either 3 or 7. Now, and both the choices 3 and 7 are given in the question as choices. Now definitely we have to eliminate one of the 3 or 7. Now let's see 3. Now we have to check the other digits, the number, the the number is given as 399, that is 5a into a is 399. So based on the digits at the units place of 399 and the digit at the units place of the left hand side number, that is 5a into a, we have arrived, we have found that the digit a can be either 3 or 7. Now we have to utilize the fact that the number is 399. We have to utilize the digits at the tens place and the hundreds place, that is 3 and 9. Now let's say if a is 3, if a is 3, so we can say that this implies a is 3 or 7. Now if a is equal to 3, let's see what is the number 5a multiplied by a. Multiplied by a, this will be equal to, we have found 50a plus a square. This is equal to 50 into 3 plus 3 square. This is equal to 150 plus 9. This is equal to 159. This is not equal to 399. So this implies a not equals to 3. So this implies definitely we are having only two possible choices of the digit a, that is 3 or 7. Putting the value of considering, assuming if a is 3, we can see that the given equation is not satisfied. 5a, the number 5a multiplied by a is coming out to be 159, whereas it is given that 5a into a is 399. So definitely a must be 7. So you can quickly check. This implies 5a multiplied by a becomes 50a plus a square. This is equal to 50 into 7 plus 49. This is equal to 350 plus 49. This is equal to 399. So a is equal to 7. So the correct choice is C. C is the correct choice. Okay, let's solve question number 10. It is given that 6a, similar kind of problem, similar kind of equation, 6a, that is a two-digit number, 6a, where the digit at the tens place is 6 and the digit at the units place is a. 6a and a and b are some digits, is equal to a83, that is a83 is a8b is a three-digit number. Then the value of a minus b. Okay, we apply the general form of the numbers to solve this equation. So we have 6a is 6 into 10 plus a, and we have multiplied by b is equal to a8b is a three-digit number. Its general form will be 100 into a plus 10 into 8 plus b plus b. Okay, so this implies we are having 60 plus a multiplied by b is equal to 100a plus 80 plus b. This implies if we simplify the left hand side, we get 60b plus ab is equal to 100a plus 80 plus b. we have to find the value of a minus b. Now from here, how do we find the value of a and b? Now this implies if I bring all the terms related to the digits to the left hand side, we get 60b minus b, and we have plus ab minus 100a is equal to 80. Now this implies 59b plus is 80. Then find the value of a minus b. $60b the right hand side, the value is 80. That means the number on the left hand side in terms of the digits a and b must be 80. Hmm, 6a multiplied by b is equal to a8b. 6 into 10 plus a multiplied by b is equal to 100a plus 10 into 8 plus b. 60 plus a into b. Hundred a, the value of a minus b. 100a 8 plus b. %, b, b. And 10a plus b. Okay, I am leaving this question as leaving this problem as question mark. I will come to this problem later on. Let's do the problem number 11. Problem number 11 says that if x plus y plus z is equals to 6 and z is an odd digit, then the number xyz is odd multiple of 3, odd multiple of 6, even multiple of 3, even multiple of 9. Odd multiple of 3. Odd multiple of 3 means uh, 3 multiplied by some even number. An odd multiple of 6 means 6 multiplied by some odd number. If it is given x plus y plus z, x plus y plus z is equal to 6. Then the number xyz. Okay. So what can I think this problem is based on the divisibility of numbers, which I have not discussed. Now, if we know xyz, a three-digit number xyz, if the sum of its digit is divisible by 3, then it is the whole number is divisible by 3. So we can see that the x plus y plus z, that is the sum of the digits, is 6, which is divisible by 3. So the number xyz has to be it is divisible by 3, that is it is a multiple of 3. So this will imply that xyz is divisible by 3. Now since if x plus y plus z is 6, and we also know that x, y, z are some digits. Now if x plus y plus 6 equals to if x plus y plus z is equals to 6, this thing clearly indicates that the digits are 1, 2 and 3. So if you have 3 digits whose sum is equal to 6, then definitely the 3 digits has to be 1, 2 and 3, but we cannot say which from the fact that x plus y plus z is z equals to 6 and x, y, z are some digits, we cannot say which one is 1, whether x is 1, whether y is 1 or z is 1. But it has to be the case that the digits x, y, z has to be the digits 1, 2 and 3. Now it is given that z is an odd digit. Z is an odd digit. Now from the 1, 2 and 3, now this implies that x, y, z are one of the digits 1, 2 and 3. That is they are different digits obviously. So if x is 1, then y could be 2 and z could be 3, or if x is 1, y could be 3 or z could be 2. Now z is given to be an odd digit. Now z is odd implies z is equal to 1 or 3. Z can be 1 or 3. Okay. Now, so the number could be z is odd. So the number is x, y, z, and the z can be either 1 or 3. Z can be either 1 or 3. So this will imply that the number x and z is equal to 1 or 3 will imply that xyz is equal to if z is 1, then xy can be 1, no, it cannot be 1, 2, 3, 1. So all the possible numbers of the three-digit number xyz, where z is some odd digit, and all the digits xyz are either the digits are one or among the digits 1, 2, and 3, and they are different. So based on these facts, uh, let's find out what are the possibilities of the numbers xyz. It can be 2, 3, 1, or it can be 3, 2, 1, or it can be, so 2, 3, 1 and 3, 2, 1, the z is 1. And if we consider the z to be 3, then the two other numbers could be, if z is 3, then 1, 2, 3, or 2, 1, 3. So these are the four possible numbers xyz, and it is asking that the number xyz is odd multiple of 3. Now definitely this number xyz is uh, is a multiple of is divisible by 3, and it will never be divisible by 9 or 6, because a number to be divisible by 6, it has to be divisible by both 2 and 3, and divisible by 2 and 3. And from the fact that, and since the digit at the units place z is said to be odd, it cannot be the whole number is an odd number. xyz is an odd number because the z is an odd digit. So it can never be, xyz will never be divisible by 2. So it will only be divisible by 3. Now the question is whether the number xyz is a odd multiple of 3 or even multiple of 3. So, okay. So these are the four possible numbers x, y, z. Now, if you consider this number, so 231, is it definitely it will be a multiple of 3. So let's say 3 multiplied by it is 77. Now 321. So 3 multiplied by 7. Now 77 is an odd number. So this number 231 is an odd multiple of 3. Now what is 321? 321, if we divide by 3, I have 107. Sorry, this multiplied by 3. Now this is also this is odd. This is odd. So the number 231 is an odd multiple of 3, and the number 321 is also an odd multiple of 3 because 107 is odd. What about 123? 123 is equal to 3 multiplied by 41, and 41 is odd. So this is also an odd multiple of 3. And the last number 213 is equal to 3 multiplied by 71, and 71 is also odd. So definitely the number xyz is an odd multiple of 3. So the correct choice is A. Correct choice is A. Okay. Let's see problem number 12. If a two-digit number xy and its reverse number yx are both odd, then x plus y is always divisible by, okay, if a two-digit number xy and its reverse number yx are both odd, so it is given that xy is odd. Now if a number is odd, it means that the digit at the units place is odd. This implies y is odd. Also it is given that yx, that is the number by reversing its digits, is yx is odd. This implies the digit at the units place of the number yx is odd, that is x is odd. So we get that both x and y From this we can say that both x and y are odd digits. So the question is, then x plus y is always divisible by x plus y. X plus y are both odd. So it is asking, then x plus y is always divisible by I think now x plus y, x and y are two digits. If a two-digit number x y by x, so if x and y are digits, the maximum value of the sum of two digits can be 9 plus 9, 18. Now how can the choices be 11 and 22? I think I did some mistake in copying the question. It must be then xy plus yx is always divisible by. Okay, so we have to say whether it seems the sum of the number and the number formed by reversing its digits, that is xy plus yx will be divisible by, we have to select the correct choice. Now if we consider this number in the general form, this is 10x plus y, and we have 10y plus x. This is equal to, if I combine the x terms and the y terms, I get 11x plus 11y. This is equal to 11 multiplied by x plus y. So definitely xy plus yx is divisible by 11, definitely. Now will it be divisible by 22? Because the choices C and D are both A and B, and D is neither A nor B. Okay, now we have to check. It is clear that the number xy plus yx is divisible by 11. Now we have to see what could be the value of x plus y. Depending on that, we can say whether this number xy plus yx will be divisible by 22 or not. Now, so x is odd, and we have found that x is odd and y is odd. So odd plus odd. Now, okay, so x is odd and y is odd. X and y are digits, so x is an odd digit, y is an odd digit. This will imply definitely that x plus y, odd plus odd is even. Whatever the value is x plus y, since x and y are both odd digits, the sum of two odd digits is always a even. No, wait a second. Yes, the sum of any two odd digits is always a even digit. So x plus y is even. This implies that x plus y will be of the form 2n for some natural number n. We don't know the digits x and y, but we can say that since x digit is an odd, y digit is an odd, so x plus y will be an even digit. Now x plus y will not be an even digit, but x plus y will be an even number, even natural number. So from that we can say that x plus y can be expressed as twice n, where n is some natural number. Every even natural number can be expressed as twice n, where n is some natural number. Now if it is so, this implies that my battery is discharging. Okay. So this implies that this implies that 11 multiplied by x plus y becomes equals to 11 multiplied by twice n, where we have expressed x plus y as twice n because x plus y is an even number. So this, which can be expressed as twice n, but for some natural number n. Now this is equal to, we can say 11 into 2 into n, and this 11 into 2 into n is definitely divisible by 11 as well as 22. So the correct choice is choice C, that is both A and B. This number xy plus yx is divisible by both 11 and 22. Okay. Now I couldn't solve the problem number 10. Problem number 10. So it was given that 6a, that is a two-digit number 6a, where a is the digit at the units place and 6 is the digit at the tens place, that multiplied by b is equal to a8b. That is, a8b is a three-digit number. From this we have to find the value of a minus b. Uh, okay. So $60B. So we have, let's do it from scratch. Okay, so applying the general form of the number on the left hand side, 6a, its general form is 6 into 10 plus a, that is 60 plus a, and we have into b is equal to a 8b, 8b. Now this implies 60 into b plus a into b is equal to a 8b. 8b. Now 60 into b, whatever that number is, its digit at the units place will be 0, because 60 into b is 6 into 10 into b, and any number, any natural number multiplied by 10, its digit at the units place is always 0. And okay, so this implies that digit at units place, since 60 into b, whatever the number is, it's the digit at the units digit of the number 60 into b is always 0. So in determining the units digit of the number on the left hand side, the 60 into b will not matter. What will matter is a into b. So digit at units place of a into b is definitely equals to b, because the right hand side of the equality sign we are having a8b, where the digit at the units place is b. Okay. Now if this is so, if a and b are two digits and their product a and b are two digits and a into b is equal to b, what can the digits a and b, what are the possible values of a and b? Okay, now from this we can say that a multiplied by b, if I take the b right hand from the right hand side to the left hand side, I get 0. This implies if I take b common, I have b into a minus 1 equals to 0. Now, b cannot be 0. B cannot be 0 because if, now from this fact, this implies if we have the product of two numbers, b is a digit and a is a digit, so a minus 1 will obviously be a digit. Now, so if the product of two digits, if the product of two digit is 0, it implies that one digit has to be 1. If we have x multiplied by y is equal to 0, this implies the possibilities are, this implies x is equal to 0 or y equals to 0. The both can be 0, or either it has to be case that one has to be 0. Now, can in this so we have b into a minus 1 equals to 0. So either a minus b is a minus 1 is 0 or b is 0. B cannot be 0 because if b is 0, then the left hand side of this equation, the left hand side becomes 0. And clearly, the number on the right hand side, a8b, is not equal to 0. It cannot be 0 because we see it's a 3-digit number where the digit at the tens place is 8. So such a number, irrespective of what the digits a and b are, it cannot be 0. So definitely b is not 0. So we will have that a minus 1 has to be 0. A minus 1 equals to 0. This implies a equals to 1. Now, a equals to 1. Okay. So, if a equals to 1, this implies from the given equation we have 61 is equal to 61 multiplied by b is equal to a is 1. So, 18b. 18b. We have this from the fact after finding that a equals to 1, if we put a, the digit a as 1 in the given equation, we get 6a into b, that becomes 61 multiplied by b is equal to the 3-digit number a8b, which becomes 18b. Now this will imply that 61b, the right hand side is the 3-digit number 18b, which in the general form will be 100 plus 80 plus b. This implies if I take all the b terms to the left hand side, I get 59 b is equal to 180. Sorry, this becomes 61b minus b is 60b. 60b is equal to 180. This implies b is equal to 3. So we are getting a equals to 1 and b is equal to 3. I'm really sorry for the clumsy solution for this problem. So this implies that we have to find the value of a minus b. A minus b is equal to 1 minus 3, which is equal to minus 2. So the correct choice is A. A is the correct choice. Okay. So this brings to an end of solving the some sampled 12 problems based on the topic of general form of a number and games with number that I discussed in the previous video, that is part 1 of the chapter of playing with numbers. I hope this set of problems will give you a good understanding of how to apply the concepts of general form of a number and games with numbers to solve this kind of problem. So if this video was beneficial to you, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video on this chapter, I will discuss about divisibility of numbers by divisibility of some numbers by the digits, some standard digits like 2, 3, 4, 5, 6, 7, 11. So divisibility of numbers is the next topic that I will discuss in the next video, that is part 3. So please stay tuned for the next video. Thanks for watching, and until the next video, take care and bye.